Welcome back to the channel, guys. It is Noah with Tutor by Design, and today we are going to be going over 7 of the hardest question types that were asked on the December SAT math section. This is going to include question types that showed up on the US and international SAT, which means that you need to know how to do them because question types are repeated all the time. So let's get started. The first question we have here is we have triangle ABC where angle B is a right angle. So if I'm going to draw this, I'll have that B is my right angle. Let's call this A, and then we could have that this is A, B, and C. Then we're given that point D lies on AC, such that angle BDA is a right angle. Now, if BDA is a right angle, that is going to mean that angle D is an altitude. Okay, an altitude is going to make a right angle with the hypotenuse in a right triangle. So we have this information. Now we're told that AB is 5 and that BC is 12, and we want to find the length of BD. What I'm thinking here is, first of all, I can figure out AC using the Pythagorean theorem. Whenever you have these questions with right triangles, you always want to figure out all the other side lengths that you can before doing anything. So I can say here that 5 squared plus 12 squared equals 13 squared, and then I can, by the way, I know that it's 13 squared because that is a 5, 12, 13 triangle, right? You can check this, right? If you didn't know that, you can just say that this is x squared. And if you put it into Desmos, 5 squared plus 12 squared equals x squared. You'll get that x is either negative 13 or 13, and obviously it can't be a negative number, right? So I know all this information. Now, something that you need to know for every SAT, because there are similar triangles on almost every single SAT, is that if you have this specific diagram, this triangle, and the big triangle of ABC will all be similar, and I'm going to show you why. So in triangle ABC, I'm going to have that this is 5, 12, and 13, and then let's draw triangle ADB. This is a right angle. I should draw that a little better actually. So I have ABC where this is 5, 12, 13, and then I'm going to have this is my right angle, and then I'm going to have ADB, and this looks a little better. And so let's make this a right angle, and then this is A, B, and D. And then I do know that this is 5, and then I also have this last triangle of BCD where this is my right angle, and this is going to be 12 then. Now, how do I know that these are all similar? Well, that's because if I look at these two triangles, they both have a right angle and they also both have angle A. So those two triangles are similar. Now, if I look at the left and right triangle, they both have angle C. So they're also similar because they also share two angles, which means that these two triangles are also similar. This is going to have that green angle, and then this is going to have that red angle. So now, if I want to find the length of BD, what I'm thinking here is I'm going to use small over big equals small over big. Basically, I'm going to take a small side in this triangle, so let's take the 12, and match it up with the big side in this big triangle that is across from the same angle. So they're both across from right angles here. So 12 over 13 equals, so now we're going to take this side that's across from the green angle, so x, and divide it by this side across from the green angle in the other triangle, so 5. Now to get x, I can just multiply both sides by 5, and then I can say that I'm going to have 60 over 13 for x. So the answer for that one would have been C. Now, let's look at this question. This one is a pretty hard one, and it's really hard to do in Desmos, which I think is why a lot of people struggle with this question type. We're given that circle A is defined by this equation, and circle B has the same center as circle A, and then we're told that the point 5, 7 lies on circle B, and we want to find if circle B has double the radius of circle A, what is the value of n? So the first thing you might try to do here is put this into Desmos, so we're going to have x squared plus y squared minus 10x minus 6y plus 5n equals 0. The problem here is that you can't really figure out any of the information here because you don't know any of the points that lie on circle A, right? And so you can't really do anything. The only thing we could do here is try to find the center, but that's not even going to help because we actually can't just make a random value for n here. We can't just determine what n is because we're trying to find it. So I can't just say, for example, that n is 2 and then figure out what's the midpoint because that's not going to be okay. I need to actually find n, right? It can't just be any arbitrary number. So instead, what you need to do here is use completing the square to figure out the center of circle A. Now, what does this mean? What we need to do is get this equation. We need to get the x's together. So I'm going to have x squared minus 10x, and then I need to get the y's together. So plus y squared minus 6y, and then I need to get the digits on the other side. So I shouldn't have anything that's not touching an x or y on the left side. Then what I need to do is complete the square. What this will do is give me the center of my circle, and it'll also give me my radius. My radius is still going to have an n in the equation, but it'll give me whatever my radius is, and you'll see how. Basically what you do is you need to take this number touching the x, so negative 10, and divide it by 2, and then you square it. And then you do the same thing with the number touching the y. You're going to do negative 6 over 2 squared, And then whatever that is, you're going to add both of those to the other side. Okay, so we're going to have negative 10 over 2 is 5 squared is plus 25, and negative 6 over 2 is 3 squared, that's 9, right? And so what you do now to complete the square is you write x and then whatever this number is before you square it. So negative 10 over 2 is 5, so x minus 5 squared plus y, and then we would have a minus 3 because negative 6 over 2 is negative 3 squared equals, and then we would have negative 5n plus 34. If you put this in Desmos, you'll notice that these two equations are going to be the same thing. Okay, that's basically what completing the square is, that this equation is the same as this equation. Okay, and so then what we can do is now we know that the center here is 5 comma 3, and we also know that this is x minus h squared plus y minus k squared equals r squared. So my r squared is this, so r equals 34 minus 5n, right? We would just square root both sides. This is going to help us because now I can say that circle B has this point on it, and we're trying to find that the radius of circle B is double. Well, I know that the radius is just going to be the distance from the center to any point on the circle. So the distance from 5 comma 3 to 5 comma 7, that is going to be the radius of B, and that's going to be double the radius of A, so double the 34 minus 5n. And at this point, I can go into Desmos and do this. So the distance of 5 comma 3 to 5 comma 7, and I mean here it's pretty simple to figure out the distance. You wouldn't really even need to do this. You could have known it was 4, but assuming it was a harder distance between the points, you could have done that. And then is equivalent to 34 minus 5n, and you would have gotten that n is going to be 6, right? I wonder if we had made this x, would it have given us a value for x? So if I just made this an equal sign, yeah, it would have given me a value for x here. So I could have done that as well, and it would have given me 6. Okay, so this question is pretty hard as well. It's very, very lengthy, which is what I think makes it pretty challenging. We're given that an ecologist compares two models that predict the number of acres of grassland in a certain area from 1966 through 1996. The first model can be written in the form of negative ax plus b, where f of x is the predicted number of acres of grassland x years since 1966, and a and b are positive constants. Okay, so basically we're given here that f of x is negative ax plus b, where a and b are positive constants. So let's just make a into 2, let's make b into 3. I'm only really going to need to look at the shape of these graphs. You'll see why I don't really need exact graphs here. I just need to look at how they look, right? And then I'm also given that the second model can be written in the form of negative c to the x plus d. So if I write g of x equals negative c to the x plus d, then I can just add sliders. And it tells me g of x is a predicted number of acres of grassland x years since 1966, and c and d are positive constants. Then it says c is greater than 1. Okay, so c is specifically greater than 1. Okay, so let's make it 2. And it looks like it doesn't matter what d is. Now it says that both the first and the second model predict the same number of acres of grassland in 1976 and 1985. So they are at the same value at 1976 and 1985. And then we want to know which statement about these models must be true. Well, let's take a look at what these graphs look like. One of them looks like this, and one of them looks like this, right? And they have to equal the same point. So let's just say we went from here to here. Right? They have to equal the same point here. And by the way, how do I know it's going to go down from 1976 to 1985? That's, by the way, what I'm representing. This is going to be the 1976, and this is the 1985. I know it's going down because you can see both of my graphs are sloping downward, right? Even though this one technically isn't sloping because it's not a line, it's going downward. And so if I look, f of x, I'll actually draw this in black to mimic that this one is black. If I go down straight, it's just going to look something like this, right? It's just going to be a straight line down, my f of x, right? And then my g of x, the green one, looks like it's going kind of curving, right? So g of x is kind of looking like it's curving like that, right? And so you could tell just by this that it looks like g of x is going to be greater than f of x, right? And so it looks like in between those 2 years, and then it looks like after that, it's going to go down, right? If I made it, I could make it so that you can actually see that like in between the points where they're equal to each other, the g of x is going to be greater than the f of x, right? And that'll hold true for no matter what. Like it doesn't matter what these points actually are. It just matters that whenever, if they're both going downwards, whenever these are equal, they are going to have g of x being greater than f of x. The SAT loves to test this concept because you actually have to understand how these graphs work. And so anyway, we're just going to have that f of x is less than g of x whenever we're in between these 2 years of 1976 and 1985, which gives us C. Okay, now in this question, we are being tested on our ability to generalize results. They ask this on the SAT a lot, and these questions are getting harder and harder every single time. We're given in this one that a marine biologist collected 28 juvenile clownfish from one coral reef and 35 juvenile damselfish from a different isolated reef off the coast of Australia. First of all, I do not see them telling me that there was a random sample taken, but maybe they will later in the question. They say they placed the fish in observation tanks, each containing an equally sized grid pattern on the bottom. To study their exploratory behavior, the biologist recorded the number of grid squares each fish crossed during their initial introduction, and again 6 weeks later. The biologist found that in early maturation, the number of grid squares the clownfish crossed was significantly more than the number of grid squares the damselfish crossed. The researcher also found that the number of grid squares crossed by both the clownfish and the damselfish decreased from early maturation to late maturation. So basically, what they found is that when they're young, the clownfish are going to cross more of the grid squares than the damselfish, but then they also found that regardless of being a clownfish or a damselfish, the amount of grid squares you are going to cross are going to decrease as you mature, right? And so based on the findings, which of the following is an appropriate conclusion? We did not take a random sample here, so we cannot attribute these results to these populations. We can only attribute these results to the two groups of the animals that were in those, that were in the reefs, right? Basically, we can't say that this is something to do with all of juvenile clownfish and all of damselfish until we take that random sample. So we're going to probably say something along the lines of it's only attributable to these clownfish and damselfish in this specific reef, right? We also didn't place them in different random reefs, right? It was a specific one. And so A says the statistically significant difference in behavior between the two age groups was caused by maturation. Like I said, you can't determine that because you don't know what we're doing here, right? Like they're growing older and we're not taking this random sample, right? We didn't take a random sample of different stages of maturation between different animals. We only did these 28 juvenile clownfish and 35 damsels. And so we can't say it's A until we take a sample where there's different age groups and we're randomly selecting them, right? Then for B, it says the statistically significant difference in behavior between the two age groups was caused by the difference in habitat. Okay, so they were picked from different habitats and then plopped into this, this reef, right? And so I'm not sure where we're talking about habitats, right? And so I'm assuming that this cannot be true, right? Because I don't even know where we talked about habitats anywhere. Now, C says the statistically significant difference in behavior during early maturation between the two groups of animals can be generalized to all clownfish and all damselfish. This one is definitely wrong. We can definitely not generalize those results because we did not take that random sample. And then this says the statistically significant difference in behavior during early maturation between the two groups of animals can only be generalized to the reefs in the study. I would say that this is probably correct, right? It can only be generalized to this specific reef, right? We can't generalize it to anywhere else. Another thing is we cannot prove causation. And by the way, this is why this question is likely an experimental question if you had seen this question, because this is also a topic that this is tested in an AP stats course, causation versus correlation. You can't prove causation if you don't take a random sample. So that's another reason as to why A and B are wrong. And so because we can't generalize, or we can't prove a cause and effect, we really can only generalize in the first place. And so A and B are wrong, and then C is wrong because we can't be talking about all clownfish and all damselfish, and so it ends up being D. Right now, in 28 here, we're given the line segment shown in the XY plane represents side JK of isosceles triangle JKL. So we're given side JK. So let's just draw this. This is side JK, and then there's going to be an L somewhere. It says JL is congruent to KJ. So it looks like, if let's just say it looked like this, then this would be our L, right? And it's saying that JL is congruent to KJ. And we're told that the perimeter of the triangle is 13 root 17, and we want to find the length of JL in the triangle. Okay, so what I'm going to do here is if I'm given JK, right, and I know that JL is congruent to KJ, and then I have the perimeter, what I'm going to want to do is I know that S plus, let's just call this A, S plus A, that's going to be equal to 13 square root 17, right? And so honestly, if I want to find JL, I don't really even need to worry about the A. Really, all it's asking here is what is JL if JK has some length, right? We literally just have to find the length of JK, right? And so I can just use the distance formula of, we're going from -7, 4 That's this point. And then we're going to 5 comma 7. So 5 comma 7. And that's going to give me this. And so if I just look at my answer choice as the square root of 17, that's not going to be the same thing. If I do 3 times the square root of 17, that gives me the same thing, right? I literally just needed to find this side length, and then that's going to be the side length of JL, right? And then if you wanted to find KL, then you'd have to do something else, right? And so that's really all we need to do for this question. Okay, now for this one, we're going to have the function f is defined by the given equation where a and b are integer constants. We have if f of 30 is greater than 0 and f of 34 is less than 0, and f of 38 is greater than 0, which of the following could be the value of a plus b? Okay, so here what we have is some function of x minus a times x minus b. Let's remind ourselves that this function, if we expand it out, is going to be x squared plus like dot, dot, dot. It won't matter. But the front matters because this will tell us that our graph is going to look like this. It's going to open upward. And so if it opens upward, if f of 30 is greater than 0, maybe it's somewhere here. Then f of 38 is less, or sorry, f of 34 is less than 0, right? Maybe it's somewhere here. And f of 38 is greater than 0. What this is going to mean is that, okay, so let's say this is 30. Let's say that this is 34. And let's say that this is going to be 38, right? 38 would be all the way here. What this tells us is that in between 30 and 34, I have an x-intercept. So let's just say x equals a, I'll have an x-intercept. And remember that when we have our x-intercepts, if I set my x-intercept equal to 0, that becomes a factor. So x minus a is a factor, which, by the way, if we look up here, that kind of matches up to what the equation gave us. And so a then is going to have to be in between 30 and 34. So 30 is going to be less than a is going to be less than 34. And then if we look here, there's going to have to be a 0 in between 34 and 38. So at x equals b, we can say. And so x minus b equals 0. So another factor is x equals b. And so to find b, I can say that 34 is less than b is less than 38, right? And so if I add these two, if 30 plus 34, that's the minimum they can be, and they're actually a little greater than that, 34 will be less than a plus b, right? And then if I have the max, they can both be 34 and 38, that's going to be less than, and this should actually be 64, sorry. So 64 is a plus b. And then that is less than, we'll have 34 plus 38, that's going to give us 72. So any value in between these, but not including them, right? These do not have greater than or equal to, less than or equal to, so we actually cannot determine, right? We cannot determine that these will be or equal to, right? And so I can say that 64 is going to be less than a plus b, right? And then it is going to be less than 72, and so the answer there is just going to be b. Okay, so now in this question, I have one of the factors of this is that, where a and b are positive integer constants, and I want to find a possible value of a, b. Now, we can usually solve this using pretty easy factoring. I can just do 10x to the 6 plus 27x cubed plus 5, right? And then all I have to do is I can say, okay, well, what are my factors of 10? And they're going to be 1 and 10 or 2 and 5, right? And then my factors of the 5 are either, they're really just 1 and 5, right? And so what I can do is I can try, if I had an x and then I had a 10x, what would I need to fill in here so that I could have 5s, right? I really could just try to guess and check. I could do 10x and I can make this plus 1. And then I can make this plus 5, right? And see what this gives me. This will give me 10x and we should actually make this x cubed, right? That way this will be to the 6, right? So we would get 10x to the 6 plus 5x cubed plus 10x cubed plus 5. And then we would see that that would not give us the 27 that we wanted, right? So that wouldn't be it. Now, if we tried with the 5 and the 1, right? If I made this a 5 and a 1, we would get 10x to the 6 plus x cubed plus 50x cubed and then plus 5. And then obviously that's also not the answer. So that's not going to work. Now, if I try 2 and 5, I try 2x to the 6, and then I try, or actually 2x cubed, and then I try 5x cubed, so 2x cubed, and then I try 5x cubed. Let's try it with 1 and 5, so plus 1 plus 5. We're going to get 10x to the 6 plus 10x cubed plus 5x cubed plus 5, and we're going to see that that's also not going to give us 27, right? And so then if I have 2x cubed, let's try 5 and 1, and then I have 5x cubed plus 1. Then that's going to give me 10x to the 6 plus 2x cubed plus 25x cubed plus 5, and you're going to see that that does work, right? So for ax cubed and b, ax cubed, it could either be the 2 and 5 here or the 5 and 1 here. It actually wouldn't matter which one because, you know, ax cubed plus b, I could have that this is 2x cubed plus 5 or 5x cubed plus 1, right? Either of these could be an ax cubed plus b, right? And so obviously only one of those are answer choices for a, b. We're going to get 2 times 5, which is 10. Now there is a way to do this in Desmos. What we can do is if I have 10x to the 6, this is basically 10x cubed squared, right? And then this is plus 27 times x cubed to the 1. And what you can see is I can just cross this x cubed out and make it into an x. I like to call this scaling down. So I'm going to turn this into 10x squared plus 27x1 plus 5. And if you divide this by a factor, so divide it by, then the ax cubed is just going to turn into a times x cubed to the 1. So it'll just become an x when I scale it down, plus b. Right, that should be equivalent to what would be the other factor? The other factor would be another like ax plus b, right? Although it wouldn't be ax, let's just make it qx1 plus r. It doesn't matter what values I give. Now let's make a list for our x, because we need this to be true for all values of x. And then it wants us to make a and b positive integer constants. So let's just make a1 and give it a step of 1 and start moving it around. So it looks like it's not going to change anything. That's because I need to then put in another value for b, right? So I really could just I could do my a and q, right? I know that a times q has to equal 10. So we could say, for example, a equals 1 and q equals 10. And we would see that they're not all integer constants, right? Then if we tried a is 2 and q is 5, then this would work, right? And we would say, okay, a is 2 and b is 5, right? And so we would get 10. Okay, so that's going to be it for this video, guys. Make sure that if you are looking for the best free SAT resources, you head over to tutorbydesign.com and check out our free resources. And if you are looking for courses where you can learn more about the SAT or one-on-one tutoring, you can find all of that on the website as well. And by the way, guys, I'm going to try to get out videos more often for you. So what type of videos are you guys looking for next? I can do English videos, math videos, or maybe even full modules. So whatever you guys need, let me know in the comments below and I will definitely get it done.